Welcome to the project demonstration of wireless control of industrial loads. So here we are going to control the industrial loads like AC bulb and a DC fan and a DC motor and a speed controlling in 10 levels, and that will be controlled through the wireless communication. We are using Zigbee here. The commands will be sent from the MATLAB. So based on the MATLAB input, like in levels 0 to 9, total 10 levels, so we can control the intensity of the AC load and the speed of our DC fan and speed of our DC motor. So the commands will be sent from the USB TTL, which is getting signals from the MATLAB, and through the serial communication it will get sent to the Zigbee, and the same data will be received by the Zigbee module, and the commands will be given as input to the PIC microcontroller. So we are using PIC 16F73 microcontroller. Based on the commands received from the system, it will control the intensity of the bulb through this triac board. There's a BT136 a triac we are using, and based on the AC zero crossing detector, this one is the AC zero crossing detector, and the triac and AC zero crossing detectors are the main input and output modules to control the intensity of the AC load. And coming to the speed of our DC loads will be done through the transistor board. So we are using BC547 transistor boards. So this transistor board for the DC motor and this transistor board for the DC fan, and the whole system getting power supply from this 230 volts AC input, and that will be parallelly given to the transformer as well as from the regulated power supply board. So this regular power supply board will take 230 volts AC input and provide us a 5 volts DC output, that is the operating voltage to our microcontroller along with a Zigbee module. And parallelly to the 230 volts to the transformer, which will step down the 230 volts AC to 12 volts of AC. This 12 volts of AC is input to this RPS board, so which will convert the 12 volts of AC to 12 volts of DC with the help of rectifier and filter. That 12 volts DC is input to the our DC motor as well as DC fan. So we can see this. So we are giving that input to this here, and again same parallelly input to the this transistor board. Same 12 volts of AC is input to the zero crossing detector. Why? Because when we want to control the AC load, so we need to control the AC waveform positive current only. So to detect the positive current starting point, so that we need to convert here using zero crossing detector. Means is the rectifier IC which will convert the AC to pulsating DC, and through the resistors we are going to convert that to potential divider voltage, which is sufficient to trigger the transistor. So the transistor will getting the trigger pulse whenever the AC positive current waveform starts, and that will be converted into the AC sine wave to the square wave signal, and that will be monitored by the microcontroller. So whenever the AC waveform starts, based on the level, so whether it's a 0 or to 100%, so it will control the positive off cycle of AC signal. So in that manner we are going to control the speed of this level of the intensity level of the AC bulb. So let us see the demonstration. So first of all we need to install PL2303, so USB to TTL converter. So install this. At the end of installation it will ask you to insert the USB to TTL converter. So insert any USB slots. So after that you can click on continue. So don't restart here, okay, and finish the setup. So after finishing the setup, from here go to this PC, right click on that this PC, show more options, and here the manage. In that go to device manager to get the COM number. So it is the device manager, and there we get the ports here. So the port number is prolific USB to TTL COM5. So if this instead of showing COM5, if it shows any error, then go to update driver, browse my computer, let me pick. So there we need to select the 2008 version, okay, then click on next. At the final it will show you the same COM number here, so just note on the COM number. And after that, so it won't change the COM number. If you change the USB, then only the COM number will be changes. Every time you insert this USB slot, then COM5 only the common number. Now open our code. So this is a code we are using, right? So open this code in the MATLAB, and that it will be open like this. So in this go to editor, and there change this COM number which we got from the device manager. Okay, COM5 we got it, so now change that. Now run the code. So if it's through the warning, so you can neglect that warning. So after getting initialized, then we'll get the command window to control the speed and intensity of the bulb, right? Okay, So this is the command window. Mainly we are controlling DC motor speed, DC fan speed and AC bulb intensity. So totally 10 levels for the each load. Just now on the receiving section. So now initially after light on and off 2 times, this light on and off 2 times here, right. So after this light on and off 2 times, the receiver got initialized. Now everything is in 0 position. Now check with, I'm getting to 9 level directly. So instead of 1, so 0 is off. So AC bulb 1 intensity. So low intensity got started. Sorry, it's off only. Right. Now level 1. So low intensity got started alert to the bulb, and level 2. So in level 3. So level 4, level 5, 6, 7, 8, 9 is the highest one. Again directly we can go to the 0. So we can place anywhere you want. So these totally loads controlled parallelly. So now same for the DC fan. Speed 1 started, 2, 3. We can get the humming sound from the DC fan. Directly we are going to set each levels directly. Same we can set it for medium, slow speed, and same for the DC motor. So when the DC motor rotates, so it needs minimum current. So now speed 3 we set. Now we can set for speed 1 again. So it rotates low speed. You can see that. So low speed now. Okay. Same for highest speed. We can go with speed 4. So only thing is, while we providing the input, so you just need to provide the gap between each and every input 2 seconds at least to get continuous output. So it's high speed again. So all are off. Let us check with. So DC motor off and DC fan off and bulb off. So in this manner, through MATLAB communication using wireless Zigbee, we can control the speed of the 2 DC loads parallelly along with intensity of AC load. Thank you.